Hi, this is the third in a series of 3 videos that outlines the prerequisite knowledge for the IB Maths Standard course. In this video, we're going to be going through equations, inequalities, congruence, similarity, and then we're going to have a look at the CASIO graphics calculator. So let's begin with linear equations. So we're going to start with two-step equations. In this case, the objective of an equation is to get the x by itself, or the pronumeral by itself, on the left-hand side. And to do that, we need to move a 2, this 2, and we need to move this 1. And so the rule I always teach is to move the number most by itself first, and that is this 1. And it's going to come over to this side as its opposite operation, which is -1. Now we're going to rewrite the equation, and that's 2x is equal to 6. This is a little times in here, so the opposite of times is divide. So it comes over here as a divide too, and so our answer is x is equal to 3. Okay, what about this one? So I want to move the 4 and the 3. The 3 is most by itself. It's a divide by 3, so it's going to come over the other side as a times. Rewrite the equation. X plus 4 is equal to 21. Now let's move this 4. It's positive 4, it comes over as a -4. Answer, x is equal to 17. We need to be able to do equations that have square roots and squares in them as well. So let's have a look at this one. In order to solve this equation, I've got to move this 5, but I can't at the moment because it's stuck under the square root with the x. So the first thing I'm going to do is move this square root. And the opposite operation of square root is squared. So we're going to rewrite that equation now. It'll be x plus 5 is equal to 49. Now we're back to a simple one-step equation. Move this 5 over, becomes a -5. X is equal to 44. This is different. Can you see that it's different? In this case, the 5 is not stuck under the square root, and so I'm going to move the 5 first. So it's going to come across as a -5. Rewrite it, square root of x is equal to 2. Now I'm going to move that square root. Opposite of square root is squared. X is equal to 4. So make sure you know the difference between those two types of questions. When we get squareds, it's going to work very similarly. In this case, I'm going to move this 1, comes over as a +1. X squared is equal to 9. There's a bit of a trick when you're doing the square root though. So here I'm doing the square root of both sides because the opposite of square root is square, so it undoes it. And our answer is going to have, it's actually going to be 2 answers. So the square root of 9 is actually plus or minus 3. And if you're unconvinced about that, remember the square means to multiply something by itself. So -3 times -3 is +9. So square root of 9 is 2 answers, +3 and -3. In this case here, I'm going to move this square first. You can see how the x plus 3 is all together in the brackets. So this is sort of isolated. So I'm going to move it. It's going to come over here as the square root. But remember when we do the square root, we get 2 answers. Have a look at that. Square root of 4 is plus or minus 2. Now I'm going to move that 3 over. It's going to become a -3 when it comes over here. And then I'm going to actually work out my 2 answers. Let's have a look at how we did that. So I've done +2 minus 3, which is -1. And then the other answer is -2 minus 3, which is -5. When we've got pronumerals on both sides, we need to collect the pronumerals together first. That's not a hard and fast rule. Sometimes you do other things, but it's a good place to start. And here's another suggestion, is that you move the smallest pronumeral to the other side. That avoids negatives. So our smallest pronumeral is this x. It's a positive x, so it's coming over here as a -x. Make sure that you adhere to the like terms rules when you're doing this. So it's going to go with the 2x. 2x take x is x, plus 3 is equal to -1. Now we're back to a simple one-step equation. Let's move that 3 over. comes over as a minus 3. X is equal to minus 1 minus another 3, which is minus 4. Okay, so in this case we're going to move the least amount of pronumeral, the smallest pronumeral, so that's the 2x. It's a positive 2x. It's coming over here as a negative 2x, and it's going to go with the 5x. Let's rewrite it. Minus 5 is equal to 3x plus 7. Now I'm going to move this 7 over the other side. It's going to come over as a negative 7. So I'm actually going to get negative 12 equals 3x. But look what I've done. Flipped it all around. And that's okay. Remember, this is an equality. The two sides are equal, so it doesn't matter if one's on the left-hand side or one's on the right-hand side. They're still equal. So in one step there, I've switched it around. If you wanted the additional step, it would have been this. Minus 12 equals 3x. And that's okay too. You do as much working out as you want to. All right, we're back to an easy one now. One-step equation. This is a times 3. We're going to take it over here as a divide. Answer, x is equal to negative 4. One more. So in this case, we're going to move that negative x. It's a minus, so it's going to come over here as a plus. It's going to join with the 2x. So 3x plus 7 equals 1. Now let's move the 7. Comes over here as a minus 7. 3x is equal to negative 6. And then finally, let's move this 3. It's a times by 3. It comes over as a divide. Answer, x is equal to negative 2. Now remember that at any point, you can use your answer to see if you're right. You can substitute it back into the question to see whether you've got the correct answer or not. Let's do that. Put the minus 2 back in here. 2 times minus 2 is minus 4, plus 7 is 3. And on the other side, put the minus in here. Minus 2 is positive 2, plus 1 is 3. 3 equals 3. It's the correct solution. When we've got equations involving fractions, one of the best methods is to actually get rid of the fractions. And we can do that by multiplying each term by the lowest common multiple of the denominators. So the denominators here are 3 and 7. The lowest common multiple of those two is 21. So I'm going to multiply this by 21. I'm going to multiply this by 21. And I'm going to multiply this by 21. And now what we can do is do some cancelling. So 3 into 21 goes 7. 7 into 21 goes 3. And now what we've got to do is try and decipher the mess. So left on this side, I've got 7x plus 3 in front of x plus 1 in brackets equals 3 times 21. So there it is there. Now I'm back to a fairly easy, straightforward equation with no fractions. Expand through the brackets gives me 7x plus 3x plus 3 equals 63. Tidy up the left-hand side gives me 10x plus 3 equals 63, and I'm back to a two-step equation. Let's get rid of that 3. It's coming over here as a minus. 10x is equal to 60. Divide both sides by 10. X is equal to 6. Sometimes we get pronumerals on the bottom, but that's okay. We can still do the lowest common multiple. Lowest common multiple in this case will be 6x, so let's multiply everything by 6x. Okay, let's cancel. 2x into 6x goes 3 times. 3x into 6x goes twice, and I can't cancel here. What's left? 3 times 3 is 9, plus 2 times 2 is 4, equals 60x. Tidy up the left-hand side. Gives us 13 is equal to 60x, and now I'm going to divide both sides by 60. So let's do that. And so our answer is x is equal to 13 on 60. We leave it as a fraction rather than writing it as an approximate decimal. Okay, last one. Lowest common multiple here of those denominators is 4, so I'm going to multiply both sides by 4. Be careful of these brackets. In fact, I'm going to put them in. Right, 4 divided 4 is 1. 2 into 4 is twice. So I actually didn't need the brackets on the left-hand side because I ended up only doing one lot of x plus 3. But I do need them on the right-hand side. expand that out. X plus 3 equals 2x minus 10. Let's move this x over. Becomes a negative x. 3 is equal to x minus 10. And now let's move this 10 over. It becomes plus 10. So 13 is equal to x, or it's better written as x is equal to 13. So just before we move on to inequalities, we're going to have a look at absolute value equations. And remember that absolute value is shown by these vertical lines here, and it means to strip the sign off whatever's inside the absolute value sign. So we need to consider two cases. We need to consider the fact that this thing inside here would be positive 5. We also need to consider that it might be negative 5. Because if we put minus 5 in there, when we strip the sign off, we get 5. And we're just going to solve both of these equations. So our first one is going to be x is equal to 4, and the second solution will be x is equal to negative 6. But let's just check that out and make sure that it's correct. So let's put the 4 back into here and see what we get. So 4 plus 1 is 5, and the absolute value of 5 is 5, so that one's correct. Now let's put the negative 6 in here. Negative 6 plus 1 is negative 5. The absolute value of negative 5 is 5. So with absolute value equations, most often you will get two answers. Inequalities. When an inequality sign like greater than or less than is used in place of an equal sign, answers won't be a discrete value like 1 or 2 or 7, but rather there'll be a range of values. So here we've got x is less than or equal to 1, and that's shown here on the number line. It goes from 1 all the way down to negative infinity. And this is x is greater than or equal to negative 4, and so it goes from negative 4 all the way up to positive infinity. Let's solve 3x plus 2 is greater than 5. I'm going to use the same method I used before for equations. I'm going to move this 2. It's going to come over as a negative 2. Rewrite, 3x is greater than 3. This is a times in here, so the opposite is divide. So it comes over here as divide by 3. Answer, x is greater than 1. Now when we're putting this on the number line, we locate the number 1, and then we're going to draw a line to the right. And when we're graphing the solution, here's the rule. If it's greater than or less than, we use an open circle, like in this case here. That means not exactly equal to 1. If it's greater than and or equal to, like this here, this sign here, then we use a closed circle. Let's look at a couple more. Solve 2 is greater than or equal to x plus 7. Now I'm going to switch sides here because I want the x to come over here. So just like I did before with the equation, I'm going to switch sides, but the sign's actually going to flip. This is 2 is greater than or equal to x plus 7. So x plus 7 is less than or equal to 2. So can you see how when I turn it around, I've got to use less than instead of greater than? Now I'm right though, I can move this 7 over the other side, becomes a minus 7. And so x is less than or equal to negative 5. So here's the first rule with inequalities. When you change sides with the inequality sign flips over. How about this one? Solve 3 minus 2x is less than or equal to 5. Let's move this 3 over, becomes a negative 3. So minus 2x is less than or equal to 2. And now I'm going to divide both sides by minus 2. And here will come our second rule very shortly, because our answer is going to be x is greater than or equal to negative 1. So when dividing or multiplying by a negative number, we flip the inequality sign. Let's have a look at why that is. I'm going to start with this 2x minus 2x, I beg your pardon, is less than or equal to 2. All right, suppose instead of dividing by the negative 2, I take it over to the other side. So I'm going to add 2x to both sides. Well, give me 0 on this side is less than or equal to 2 plus 2x. Now I'm going to take this 2 over as a minus 2. So minus 2 is less than or equal to 2x. And now finally I'm going to divide by this 2. And that will give me negative 1 is less than or equal to x. And now I'm going to turn it all around. And what happens when we turn it all around? the sign flips. Okay, now this is quite a long way of doing it. This rule is much quicker. So whenever you're dividing or multiplying by a negative number, you flip the inequality sign. Sometimes we get inequalities that have got three sides, like this one. So we've got 3 is less than or equal to x plus 7 on 2 is less than or equal to 4. And that means that this expression x plus 7 all over 2 is in between 3 and 4. But what we can do is just perform the opposite operations to all three sides. So I'm going to start off by multiplying by 2 in each case. That will give me 6 is less than or equal to x plus 7 is less than or equal to 8. And now I'm going to get rid of the 7 by subtracting it. That gives me minus 1 is less than or equal to x is less than or equal to 1. Now when you draw this on a number line, it'll look like this. It's a little bit difficult to draw these little coloured in circles things, so you have to bear with me, but it'll point inwards like this. Oh, I did pretty good actually this time. Okay, so that's how we would draw it on a number line. Sometimes you need to split up the inequality and solve it in two parts, and that will be because this is a negative here, and that will flip the signs. We can still move this 2 to begin with though, so we're going to multiply everything by 2. And I'll get rid of that. So that gives us 8 is less than 1 minus x is less than 12. But now I'm going to split it into 2 bits. Have a look. So 8 is less than 1 minus x, that's that part. And then 1 minus x is less than 12. Okay, I'm going to get rid of this 1 and take it over the other side as a negative 1. So 7 is less than negative x. And I'm going to do something sneaky here. I'm going to take this across here as a positive. And this across here as a negative. And so x is less than negative 7. Okay, let's move on to this guy. Let's get rid of the 1. Comes over here as a minus 1. Minus x is less than 11. Times both sides by negative 1. That'll get rid of that negative on the left-hand side. But it's also going to flip the sign. So x will be greater than negative 11. Now let's just have a look at this one when we graph it. So I've got minus 11 and minus 7. We want it to be greater than negative 11 and less than minus 7. So we could actually rewrite this as negative 11 is less than x is less than negative 7. Okay, let's move on to some geometry. Triangles are congruent if they have 3 pairs of matching angles and 3 pairs of matching sides. But we don't need to find all 6 facts in order to prove congruency. There are 4 sets of minimum conditions that we use to prove it. They are side, 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 angle, angle, side, side, angle, side, and right angle, hypotenuse, side. Now to write a congruence proof, we state the 3 facts with reasons, and then we write a summary statement including which congruence proof you used. So let's have a look at these 2 triangles. Our first fact is that BC is equal to MN, and our reason is that it's given in the diagram. Our second fact is that angle B is equal to angle M, and that's a right angle. Our third fact is that AC is equal to LN, and that's given. Therefore, triangle ABC is congruent to, that's what this symbol is, triangle LMN, reason, right angle, hypotenuse, side. Just a couple of things to note here. That's the symbol for congruence. You don't have to write out the full reason, you only need to write the initials. And we put these vertices in order. So A matches L, and B matches M, and C matches N. Let's have a look at an embedded diagram. So prove that triangle ABC is congruent to triangle CDE. Okay, so the first thing that we know is that AB equals DE is given, so this side here. The second thing we know is that this angle here, ACB, is equal to this angle here, DCE, and they are vertically opposite. And one more, angle BAC is equal to angle CED. So that's this angle here equals this angle here. Reason, alternate angles on parallel lines. So there's our three facts. And we've got angle, angle, side. So we say, therefore, triangle ABC is congruent to triangle EDC. Reason, angle, angle, side. Here's another one. Prove that the triangles OAD and OBD are congruent. All right, what have we got here? First thing we've got is that OA and OB are equal because they're radii, that's radiuses, of the same circle. The second thing we have is that OD is common. Okay, it's a common to both triangles. It has to be equal. That fun little S that I just drew there, that means that you've got a common side. And finally, we've got that right angle, haven't we? Angle ODA is equal to angle ODB is equal to 90 degrees. Therefore, triangle OAD is congruent to OBD. Reason, right angle, hypotenuse, side. Now we can use our congruence proofs to actually prove geometrical facts about different shapes. So here's a triangle ABC, and it has AB is equal to AC. So we want to prove that angle B equals angle C. Now we know it's an isosceles triangle, but we're actually wanting to prove that the base angles are equal. The first thing we do is construct a line from A through the midpoint of BC, and we're going to call that D. And then we're going to set up a congruence proof. All right, here it is. AB is equal to AC. That's given in the diagram. AD is common. Do you remember what we draw for that? This little guy. BD is equal to CD. So this bit here is equal to this bit here, and that's because D is the midpoint of BC. Well, there's our three facts. Therefore, triangle ABD is congruent to triangle ACD. Reason, side, side, side. Now, once we've used congruence to prove that two triangles are congruent, remember how I said there are 6 facts before, 3 angle pairs and 3 side pairs? We've used 3 here, but as soon as we've proven congruence, all of the other facts are suddenly true. So we've used the 3 sides, but now we know that this angle would have to equal this angle. And so our last stage of our proof will be to write, therefore angle B is equal to angle C. Reason, corresponding angles in congruent triangles are equal. Now, 2 figures are similar if one can be enlarged to be congruent with the other. So like this. Okay, so they will have the same shape, but not necessarily the same size. So these 2 here are similar. So it will have, in this case, 4 pairs of equal angles, and the sides will be in the same ratio. Now, like congruence, there are 4 established tests for similarity of triangles. This is the most common one, equiangular. Okay, it's not called AAA. You actually have to write the word equiangular. Unlike congruence, we only need to show that 2 pairs of the matching angles are equal. Why is that? Well, that's because the angle sum of a triangle is 180 degrees. So once we know 2 angles, we automatically know the third. So there's the most common test, equiangular, but we can prove that the matching sides are in the same ratio, and we'd have to do all 3 sides. We could find 2 matching sides in the same ratio and the included angle equals. That's like that side angle side test for congruence. Or in right-angled triangles, we can show the hypotenuse and a pair of matching sides are in the same ratio. So there you go, 4 tests of similarity. There are no abbreviations like SSS, and the most common test we use is finding 2 pairs of matching equal sides. We can write equiangular, but we can abbreviate the reasons like this. 2 pairs of sides in proportion, included angle equal. It's just got to be legible to the marker. Here's an example. Prove that triangle ABC is similar to, see the difference in the symbol? Okay, they're vertical lines instead of horizontal. It's similar to triangle ADE, and so that's this one here being similar to that one. Okay, we're going to use the equiangular proof because of the parallel lines, we've got equal angles all over the place. The first one is that this angle is common to both. So angle BAC is common. And then the second one, you just pick whichever one you want. Which one do we do? ABC. So here is equal to ADE. Reason, corresponding angles on parallel lines. Okay, we've done it. Now just sum up. Therefore, triangle ABC is similar to triangle ADE. Reason, equiangular. Once we've proven similarity, we can find unknown angles or sides, just like we did with congruence. So in this case here, given that triangle ABC is similar to triangle DEC, find the value of angle EDC. And so let's have a look which one that is. Angle EDC. So we know this triangle is similar to this one, and so that angle matches that one. So angle EDC is equal to 50 degrees. Reason, corresponding angles in similar triangles. Find the length of DE. Now this one's not equal to 6. Can you see where DE is? It's here. Okay, it's going to be in the same ratio, or those two sides are going to be in the same ratio as this one is to all of that. So we're going to set up an equation with this guy on top. It's going to go DE over 6 equals 4 over 7. Multiply both sides by 6, and so DE is equal to 3.4. And our reason is sides in similar triangles are in the same ratio. All right, let's move on to the last part of this video, which is about using the graphics calculator. We use the CASIO at the school that I'm at, so that's the one I'm most familiar with. So you can stop the video if you use the Texas Instruments one or the Sharp, because I have no knowledge of that. But there are 2 exam papers for IB Standard Maths. You have a non-calculator paper of an hour and a half, and then you have a graphics calculator required paper of an hour and a half. So the main menu of the CASIO looks like this, and if you use the little down arrow there, then you get this screen as well. There's lots of different things. Some of them we will not use. But a couple of things. For the basic calculator, you go into 1, which is run, and you would enter your calculations as you would for a normal scientific calculator. You've got lots of things here. You've got sine, cos, tan, you've got log, you've got e, you've got fraction buttons, all sorts of things here. You've got a cube root in there. You've got 10 to the power of x. You've got a way of changing mixed numerals there to improper fractions, and this is your fraction button, and that's how you enter mixed numerals there. And you've got your inverse trig up there as well. Lots of different things to use. The ABC is the fraction button, so you hit it, and then you can enter your fraction. And F to D, which is this one here, toggles between exact value and decimal approximation. So it will actually simplify surds for you and give you the surd exact value, sorry. And then if you hit that button, it'll take you to decimal as well. So it's quite a useful button, that one. The calculator has trig tables in degrees and radians. You will be using radians later on in the year, and you need to know how to turn between them. So to switch between, go to Setup, which is Shift menu, and go all the way down to Angle, which is on the first page, and you'll see here degrees, which is F1, radians, which is F2. Okay, the standard default, it'll be in radians. If you want to clear the memories or reset the calculator, you go to System, which is on the second page of the main menu, or you can go to Memory here. Okay, and then you hit F5 for Reset, which is here. You can reset the setup data, the main memory, the storage memory, any of those that you want to. If you want to completely initialize it, you go to the next page, which is F6, and then you initialize all. You'd only really be using that if you got the calculator into some sort of mode that you didn't know how to get out of. And then the last thing that I want to talk about is exam mode. So when you go into your exams, you have to go into exam mode, and that disables any programs or notes that you've entered into the calculator, because it's the whole thing that you can program the calculator to do things, and you can take notes in it. So exam mode disables that. And what you do is you hold down, would you believe, the COS and 7 buttons, and then you press the AC on button. And it'll come up and say, do you wish to enter exam mode? I wouldn't suggest doing this, by the way, at the moment. Hit F1 for yes, and then F2 to continue. Once you're in exam mode, an R will flash in the top right corner, and it will do that for the whole time. And here's the thing, your calculator will automatically exit from exam mode 12 hours later. The only other way to get out of exam mode is to connect to a computer or to connect physically via USB to another calculator. That's to stop people, in an exam getting out of exam mode. So basically, if you have a go at that, don't hit F1 for yes at this point. Not that it's the biggest thing anyway. As I said, all it does is disable any programs or notes that you've entered, but it does have this annoying flashing R, which will bug you. So have a look at it, but don't go into exam mode until you actually have to. All right, that brings us to the end of pretty much everything that you need to know before you start this course.